Okay, here's one of my big questions. The n-hypersphere of maximal volume, I realize it's a little distorted, but the n-hypersphere of maximal volume, this is essentially our realm of persistence as we know it. Okay. Where's the knot come in? What is the level? Because I initially had some intuition. I read some things and I'm like, okay, now are we talking about like one of those, okay, we have 7 circles, again, not to scale here, 6, 7. Is it something like that? Or is it actually 10 to the negative 18, 10 to the negative 8 meters? So it's actually really, really, really small there. I'm curious your intuition to what's going on with that. Because I think this relates to what Kevin was just kind of saying right there. So I was, if it helps,
That's a brilliant question.
maybe it will help all of us.
Yeah, it's a brilliant question. Let me preface with my story updates with every detail I get, but the best starting place I would say is instead of thinking of the sphere as just a single, I imagine you're thinking this is 3D here, right? Just a spherical bound, and they're trying to look inside. Remember that it's a sphere that presents itself this way and then inverted, and then this way and then inverted, and then this way and inverted. Okay, or the Riemannian sphere. It's 2 spheres connected to each other at the boundary. But you don't have to think of the boundaries staying smooth. The way that they connect can break all up into anyway, so long as they pull off what they need to do to maintain the balance between them. So it's not going to be the smooth connection. It's not that you have a second sphere that's the same size over here, and this point mapped to that one, and this one went to that one, and this one to that one, and so on, and fill them all out. It's not a perfect, smooth mapping. It's a fractal mapping. Okay, that breaks up all the points between here and there. But again, it's not 2 spheres side by side. It's one falling apart and partly falling together somewhere else, right? But that process together then turns the sphere inside out, and then it does the opposite, but it's always presenting itself inside out, outside in, inside out, outside in, from the projection that's making it. That's what the projection's doing on the inside. It's not a speaker that's just saying and pushing the wave out. Okay, that projection doesn't feel like a wave that's just being pushed in and out, in and out. It's more complex, a thing that's turning inside out on itself, right? It's a Mobius bound thing, or a spinner. Okay. In both cases, we project a sphere.
Yeah. Does it have to break itself in order to?
Yeah. It's partitioning up on the inside, obviously. Otherwise, there would be no way to connect all the points to all the points.
So there's a point where it steps from
being
a normal sphere to an inverted sphere.
So think now, this is the biggest scale of the projection, and this is its inside-out circle. Okay. So that's just the Planck temperature one. Yeah. But we want to look inside now, and there's going to be a much, much smaller one. Yes.
Okay.
Yes.
Okay.
Yes. So this is the Clifford torus.
Clifford torus, yeah.
Yeah. So and let's be more general. The Clifford torus is a general kind of statement for all the kind of intersections you can have between a circle and a circle. Yeah. Okay. We're bounding a domain with 2 different circles, and we're letting the circles move around so that bound inverts on itself. Okay. That's exactly what I mean. That's actually what's going on. Out here, it always looks spherical. It doesn't matter if it's inside out or outside in. Right. It feels spherical and flat if you're on the 1 scale. Okay. Yeah. But as you go into the bounds, that's what the bounds themselves are doing. They're turning inside out on each other. But that's what the shape is doing. Its inside structure is doing that. The torus bound are going to have to be a total of 4 dimensions. Okay. Why? Yeah. Because there's 2 circles intersecting. Each circle defines a plane. Okay. A planar direction. And they can be intersecting in any way, and you can say that that's true. And there can be different sizes, and you can say that's true. So that's basically what we have. The torus construction, you can allow any size difference of them. Okay. There's an equation for the Clifford torus that says this. X1, some dimension 1, unspecified, times x2, another dimension, has got to be equal to x3, x4. Now, this is the most general way of talking about all possible Clifford tori, because I haven't specified the x's. But if it's a Clifford torus, it's 4-dimensionally bound, and it's, so here's the 4 dimensions, and those 4 dimensions have to be related in this way. 2 of them pair up to equal the other 2 pair.
Product of any two orthogonal characteristics is equal to the product of the remaining 2 characteristics?
Yeah,
Okay.
not any 2, just 2 of is equal to the product of the other 2. Because it's one circle and another bigger circle. So there's 2 that go together and other 2 that go together. But when they go together in the Clifford torus, they have to be equal because they invert.
Right.
Yeah.
I just mean there's not another orthogonal feature dimension left out.
Yes, there's not. It's only 4 dimensions. Exactly. And you could think of this as, well, you can see in the Clifford torus, when you're dealing with 4 dimensions, there's still a hole inside them.
Yeah.
There's still a minimum thing that no matter how you go around, you're still on top of a minimal distortion. So there's another dimension, just not in this dynamic, responsible for its presence, but not included in its dynamic.
Minimal distortion creates the hole?
The hole, yeah.
Because, like as you tighten the hole, the distortion would be greater and greater?
Well, if you think the torus, the Clifford torus that you're seeing, if you freeze frame at any position it's in, that boundary is literally the bounded structure of it at that point. Okay, it keeps changing on itself, but that's at that point the bound. The smallest hole in that boundary is what's holding up the whole structure right now. Right?
It's like a keystone.
Yeah. Yeah. Okay. So here's the general Clifford torus structure. It's 4-dimensional. 2 of them have to pair to equal the other 2. The product of 2 has to equal the product of the other 2. Well, do we have anything in our model that looks this way? Does that sound familiar? Anything 4-dimensional that you remember? We have every single equation has a primary action on a set of boundaries and a terminal action on a terminal set of boundaries, which are how many? 4. And our terminal set of boundaries, we have a symbol like this for them, but it equals the Planck length, that's 1. The Planck mass, that's the second one, divided by the Planck charge, that's the third one, and then another Planck charge. That's our 4 dimensions. Now, in what way does this have anything to do with this?
They both represent 4-dimensional realities. They're 4-dimensional.
Well, I mean, if this was like this, wouldn't you expect like that, let's say something to do with the Planck length, it's the rotation 1.
Yeah.
The Planck mass is rotation 3.
Okay.
And the Planck charge, well, actually I need to write it the other way, not divide by anymore. I'm going to move it up. Equals the Planck charge, which is rotation 2 times rotation 2.
Yeah.
That's true. The Clifford torus structure is the simplest possible 4-dimensional bound. The bound we're talking about are projection having. The n-hypersphere of maximal volume is internally bound 4-dimensionally, shaped like a Clifford torus. So what we're saying is we have a 4-dimensional construction out here, and we're talking about the n-hypersphere. The hyperbolic figure 8 knot and the n-hypersphere are bound together naturally to begin with. Okay, remember the equation for the hyperbolic figure 8 knot. Remember this picture, but I need the space. Okay, and we're going to stay in that conversation for a bit. So keep that in your mind. I want to fill in before we're done. There's going to be in the gap here, making everything happen. It's twisting together from the hyperbolic figure 8 knot, meaning the structure of the hypersphere, its positive projection and its inverted projection, or negative, right? Both of them are bounded by the outside bounds that are bounding the hyperbolic figure 8 knot. It's really that simple. But let's show you an equation for it. The hyperbolic figure 8 knot, that's the symbol for it, right? The volume of the hyperbolic figure 8 knot is equal to I times the dilogarithm of 1 over the imaginary golden ratio minus the dilogarithm of the imaginary golden ratio. So using the argument of the imaginary golden ratio, which means trivially we're dividing a domain under rotation into 1/3 and 2/3 rotations, okay? So it's asymmetric, it's not half and half here, it's 1/3 and 2/3. And we're fitting it all together to make a volume complement. It's all squeezed together using I, and it just equals this volume complement. We look at this equation now, we want to say, all right, that means we've projected under a rotation a volume complement that closes. What about all the other pieces now that are on the outside of that closure? What are they? All the pieces, and how many pieces are there? Well, we use the same exact equation under the same exact arguments, and we try all the possible plus or minus signs. Right? Do all positives, try all positives and this one negative, and just do every iteration is going to be exactly what? 5 times 2 to the 5.
Yeah.
2 to the 5, which is 32. There's going to be 32 expressions of the hyperbolic figure 8 knot structure. One of them makes this, closes in on itself, right? The other ones are doing what? Forming the pieces of the stripes of the boundary that's twisting outside into the projected sphere and in the inverted projected sphere. They keep doing it over and over. They're all riding on top of this, and they're riding on top exactly on it. They're a manifold. They are the other pieces making up this. And to find them, you literally just put in different plus and minus signs, list them all. Now you've got all 32. All 32 actions responsible for this one balance. And remember which domain is 32? Temperature. The external projection. The whole thing. Right? So the whole external projection says we have all these 32 pieces. This one's hidden on the inside. From the outside, you're never going to get it, but it's one of the pieces of the form. Right? It just turns on itself. That's why you can't get to it. Anyway, that's it. That's that simple. And when you write down the list, let me pull that up.
Yeah, it needs to connect on itself.
Yeah. Okay. So literally we're running through the possible iterations of plus and minuses in the arguments and signs. Right? That's it.
Oh, yeah.
All the way down, all the way down. And then writing down, just asking Wolfram alpha what it equals and writing it down. Okay. And obviously this is 8 over square root of 18 times 32. That's going to be 24. 8 over 24 reduces, right? But I'm writing it all that way so you can see the 8 mass derangements related to the 18 and 32 charge and temperature derangement in the structure. Okay. That one equals 0 real. There's nothing in the real, but I'll show you the factor I'm comparing them all to. 8 Giesking constants, square root of 18 times 32. That's the long way I'm going to write this at this time. Well, we'll shorten it as we go, but I want to do this for a reason. And then there's an imaginary component that's not 0 in this one. It's 4 times this gamma of, I'll write 5 since I'm not got a blue pen. It's supposed to be a red N, times I. Okay, now in every case, no matter what we do, to the signs here, in every case we're going to get a different number here and the same thing in the parentheses. Follow me? I mean, sometimes the number's 0, so it just destroys all this, but still it never deviates from that. All right, there's a 0 and -2, -1, -3, and then I get -6, 0, 6, 0. And this is the one we started with that's the hyperbolic figure 8 knot. So this is the negative hyperbolic figure 8 knot. Yeah. Equal sign there. Okay, follow what I'm being lazy and not writing down all the equations equal to. You can go easily check that. But this is what it spits out. We get somehow in the real there's a 1, 1, 4, 5, 5, 6, 6. Of what? Of these. and 2 zeros, and if you want to include those. Okay, and this one, we get a -4, 2, 3, +3, 1, 1. What is this telling you now? These two are the same thing. These denominators are the same. Okay, so maybe I should write even longhand, put that in there too. But we're comparing squarely intersecting a sphere, a sphere in the imaginary direction, under division of the 5 rotations, hyperbolic rotations. And over here, the same thing goes there, but what they're equaling in they're splitting up into the 18 and 32 directions, right?
Yeah.
On what? 8 Eastking constants. Okay. Now, what are the splits? What do these numbers mean to us? And this is something I think you're going to really love. There's a shape. It's not a Platonic solid. It's more complex than that, but it happens to contain all of the Platonic solids. Okay, it's called the rhombic tricontahedron. And it's only made of golden rhombuses, meaning the ratio of these the connecting points from point to point is the golden ratio in every single one. Now, when you take different vertices, different sets of vertices in that system, you happen to get the Platonic solids, and when you connect the faces of that other one, you get the last. So we literally get all the center points of the faces. So we get all 5 Platonic solids in this one structure. The rhombic tricontahedron's vertices encase an arrangement of 10 tetrahedra, 5 cubes, 1 icosahedron, 1 dodecahedron, and via the centers of its faces, it contains 5 octahedra. Let's write those numbers down and see if any pattern pops up here. We got 10 tetrahedra, 5 cubes, 1 icosahedron, 1 dodecahedron, and then in the faces of all that, 5 octahedra. Ouch. Right? You agree these are the
Yep.
Platonic solids. They're all in one cage structure, which happens to be made only of golden ratio pieces. Beautiful. Good start, especially because if you're trying to relate this to the gamma function structure, which divides via golden ratio and the imaginary golden ratio. Right? Okay, we want these things to be accounted for. Can we compare that to anything over here? Oh, I know I did it wrong. I'm supposed to divide the list here. It's symmetrically, and then invert all the signs for the other half of the 32.
Okay, so there was 16 there.
Yeah. Okay, sorry. So here, starting from here up, or this way, can you make any connection to those? What if this one and this one were the same sort of thing? We'd have 10. And then we'd have 5 and 5 and 1 and 1.
5, 5, 1.
Okay. Yeah, it might literally be the cage structure, the transform restrictions allowed. Okay, and notice they hold, I mean, the symmetries in this one thing are really, really profound. It's not just that we have a structure that holds all the Platonic solids, is that structure itself is connected to the arguments, the division arguments, the rotation arguments of the hyperbolic figure 8 knot and the gamma function. Right? A real direct, exact connection to the structure we're talking about. Isn't this beautiful and simple?
This would have gotten me into math many years ago, just because it just seemed for me again, I realize a lot of teachers are doing like the best they can, stuff they got to follow the agenda and everything, but just seeing things like this gets me excited, man. This gets me excited, and I don't think I'm alone here. So.
Now we are saying that there's 4 of these, to be clear. somehow, whatever that means, okay? Because we have one of these accounted for in one of this, and then there's another whole, this is inverted below here, -6, and then +5, and so on, right? And then the whole copy is all inverted again with negative signs on everything. Or everything that was negative becomes positive, everything that was positive becomes negative. Okay, but then we still have this side to count for, okay? Maybe we're saying the real side, the real connection of these actions is bound perhaps via these exact shapes under that one exact structure. But then we have the other side of the story, the imaginary side that's doing what? This is the projection, not the bounded part, but the part that's, here, things are going like this, like in a hurricane wall, and one side of that wall is going back around, and the other side's not, right? So the projection's the outside. So inside, outside, you can think of as of the form. Okay, and the inside's bound this way, and the outside's got this structure, which means, this is literally up to date where I'm at in the story, so I don't know, ... The only way we make sense of it is by having consciousness attempting to make sense of it. Yeah, it's really fun too. Isn't this really like spooky geometric?
It is.
Yeah.
It's spooky simple geometric. We use the simplest manifold possible, somehow connects to all of the Platonic solids, and it's not very complicated. I understand that you may have never even heard of a dialogue rhythm. So now we need to understand what that means, right? But it's a function for you at this point, okay? An exact specified function that has this imaginary ratio argument, which again is the imaginary golden ratio is equal to -1 to the 1/3. Cool. That's a number to me just as cool as I.
Well, I mean, a lot of folks probably haven't heard about that because, as far as I understand, that's not even in Wolfram Alpha. It's not even
Not yet.
exist in the Wolfram language.
Not yet. It is in Math Stack Exchange. There's a couple conversations on it there. But yeah, you're right. There's also a couple numbers that you can derive about primes that aren't on Wolfram Alpha. I don't know why, but that's interesting also. So yeah, we're still at the forefront, I guess, of discovering some of these connections in numbers. Cool. All right, so the story, at least as far as algebraically, has gotten really, really simple, right? We actually have one structure. It's the 32 equations, okay? And one piece makes this, the negative hyperbolic. Another piece makes that. There's 4 of them, actually, right? There's going to be 2 negative and 2 positive in the whole set, okay? And the outside domain is maintaining all 32 of these actions. But the inside domain is is the action on the inside that doubles back on itself. So there's a boundary between. If you're in the outside, you won't get there. If you're in the inside, you never get the outside. But it's still all dependent on each other exactly. There's no other gaps or missing pieces. There's no other plus or minus error. It's just this set of rotations into each other. Yeah. And you can see how we can extend now visually how this will then be 8 somethings and 18 somethings and 32 somethings breaking up, right? The division and rotation are going to have these sorts of comparisons fitting into each other. So I feel like we're just a couple steps away from having that final drawing of exactly how it looks and code it in a computer and then animate it and get the pieces to move and show, in a much more rich way. We really need the visual. These equations are fantastic to have, but when we have a visual saying the same thing, it makes a much bigger impact in your mind. Yeah.
To the Platonic solids and back again.
Ooh, that's a good book title.
It's one of those things where people will propose something, and it's like, okay, well, this is great, and then it's like, well, that's not actually explaining what's going on, and then you get more and more technology, we have more and more consciousness. Focus on these things to figure it out. That's why I tend to believe that any sufficiently crazy idea is indistinguishable from madness.
Yes, especially
like
at first.
But it's really.
We're saying that akin to becoming aware of electricity and the electron, and I know it took a long time to build up the infrastructures that would take advantage of that knowledge, but we were all born in the world that had. So we can, vividly feel how important it is to know about the electron. For at least someone in humanity who have known, right? Because you benefited your whole life from that. Well, we're saying now that it may be that this structure can be used to code transitions from stable to stable to stable to stable, right? Until we get to put in a sequence of transitions about this structure to get from one state to the desired states. Whatever stuff you throw into the machine, it's going to take that as the input state, physically take it, and then transform using this logic. Meaning, we will, and why would we be able to interface with physical things instead of just the world, the virtual world? Because we're saying this is the logic of the currently existing physical things. We're saying we're uncovering the balance that's keeping these pieces together to begin with, the forms all around us already, including the stuff you think is garbage, right? Which means understanding how the boundaries are holding things together gives you the ability to do transforms between garbage and gold, or garbage and anything you want, food. You just need mass, because if you throw something with mass in, you've given it an extremely high amount of energy, right? You don't necessarily want to convert it all to energy via E equals mc squared, but you might want to convert it to a real tomato, right? One that tastes ripe instead of the stuff we have today. Yeah, I mean, and then you could, if you understand the transforms between the loud states, you should be able to record and program all the desired states you want, all the best meals possible, and put dirt in the machine and convert to legitimate, exact what you want, right? I mean, that's what it implies. It's complex, yes, it has to do thousands, billions, who knows how many transitions, but we already live in a world where it's not daunting, right? It could be too big, but it's not going to be too big. Why? Because nature's already doing the things we want done within our time scale. Food grows within our lifetime naturally already. And to be able to reproduce those same boundary arrangements is definitely available, right? There is no doubt about that. So anyway, that knowledge is priceless. It's worth more than anything on Earth right now once it's understood how to be used, right? To be able to use the electron, to know the electron exists is valuable, but then you have to be able to implement it. You have to actually get electrons to do things and build machines and infrastructures that can, organize that ability. Okay, that's where we're at though. That's where I think we're at. We're at a level of understanding that we're accurate enough to believe that this whole thing's saying the same story, right? We're still doubting details, especially if it's in the noise of measurement, okay? And we'll always be doubting and questioning, but we found a story that seems to coherently, according to all the constants in nature and all the mass particles, there's more doubt there because less accuracy, but still, all of them are agreeing to this simple story. We got one projective balance that defines the minimal internal volume complement. So if you're going to have a balance, sure, it might be really hard to get one at first, but if you're going to have one, the easiest one to get is this one, the minimal volume complement, and riding on top of that, inverting backwards all these other pieces. There's 32 exact pieces in the whole structure, but they have this exact form. Compared to each other, they're exactly these largeness and so on, which builds a cage structure in the whole structure, in all the pieces together at the same time, that maps, it seems, 4 of these. Okay? That's a pretty beautiful and short story, and profound. It's really profound because this gives us a way to understand chemistry in a whole different way. Your question at the beginning was, how am I supposed to be visualizing this sphere? And when you have the answer to that question, you understand intrinsically chemistry, all of chemistry, why it's available, why those are the stabilities and so on. The answer is the picture of the projected 2 spheres that are held together, the boundaries they're breaking up on, right, that 4-dimensional construction, really balances exactly like this, exactly in these 8, 18, and 32 divisions. Okay? Yeah. So if you have that one balance, that one projective system, and then you could say color code the boundaries, make it easy to see, and zoom in and so on, develop your intuition on these things. The point is the presence of these things in the simplest projective balance means there's also now an availability for you to give this balanced system, which contains so much momentum, so much boundary, so much energy, you can give it more. If from the outside an undulation comes along and charges this thing up, it could just pass through the whole thing, distorting, but you wouldn't notice from the inside, right? Or it could be the right amount of energy to loop up one of the existing partitioned regions, twist it twice instead of once, every time everybody else does its thing, right? And every existing partition in there now are available to be done that too. So as you push more and more loops up in the existing loops, what do? You turn the thing into from being this minimal structure, which defines, if you zoom really in, the hydrogen atom, and if you zoom out to the second time around the Mobius connection, the helium atom, or our universe, right? Defines that. But then if we add more loops, it doesn't define exactly that structure anymore. It's that structure with a modified extra loop in it somewhere. One of the loops, depends on which one you put. Put the smallest loop, then you can loop up in mass first, right? And fill up all the mass loops, that's the smallest ones, and then you add more in charge, and then all the way up in temperature. But as you do that, you're literally changing the structure of that whole balance from being a hydrogen-helium structure to a lithium and beryllium and boron, nitrogen, oxygen, freon, all of the atoms all the way down until the last one of these are looped up, and you now have the heaviest atom on the periodic table of elements, right?
Yeah.
You've twisted up the domain so tightly, it can't be twisted up anymore. There's no other things to be looped again. Everything has been double looped. Okay, I'm trying to get people to suspend their skeptical voice because I think it's the only one that's been nurtured in their life. And it's a beautiful voice, but it's supposed to come in at the end. Right? If a skeptical voice stops you from hearing the beauty that comes out of other people's mouths, then you're not really exposing yourself to the beauty of the world. You need to be exposing yourself to the beautiful stories and picking among them. Here we're saying we've been looking for, in the numbers of the measurements, the constants of nature and mass measurements, right? We've been systematically organizing them, making sure that the representations are all in the same sets of dimensions, right? That everything is comparable together. And in that pattern, we've found a very simple clue that at 7 significant digits, the pattern picks up a second piece, meaning whatever this construction is coming from, it's coming from a big piece and a piece that's 10 to the negative 7 times smaller every time. And that simple clue allows you to take every measurement, once it's all organized and paired in the same sort of way, and decode them into what their geometric actions are on what boundaries, to reveal some hidden essence in nature that you didn't know was there before, in detail, both the boundaries that are there and what they're doing to each other there. Okay? And that'll allow you to understand the action we're calling the constant of nature. It's literally one of the intersections of this construction, exactly one of the intersections of this construction. Okay? So all of those intersections, maintaining this persistent domain, give us an ability then to immediately predict changes in it that alternate from just a hydrogen-helium geometric representation of a universe to now a lithium universe, right? Or all the way down the chain. But it also cuts off at the heaviest element. That's the end of the possibilities in our structure. Why? Because it only has 8, 18, and 32 possible loops. And all loops can be looped up clockwise and counterclockwise. And then you're done. And that fills the whole periodic table. So there's the story in general broad swath, but also access to the exact equation you can then put in Wolfram Alpha on yourself, by yourself, right? Find all 32 versions of it, ask it what it equals, find this. It's an investigation that nearly everybody can do.
It's incredibly, it's complex, but it's finite.
Yeah,
It's doable.
it's big, it's a big project, but this is, I would argue, most exciting because it's the biggest project there is, right? If you were to ask, what's the thing anybody can do during their life that aims towards the highest aspiration anyone's actually clarified yet? What's the highest goal ever uttered that's not nonsense? It's something you could direct yourself to. Solving the theory of everything, figuring out the structure of reality, understanding the domain you're in before going about in it. Yeah. We're so happily going about our lives that we've made up, the dramas that we've imagined. Well, we haven't even stopped to figure out what we're in. Right. We don't even know the rules of reality. We're not even using the value around us at all. Yeah. Right? To us, dirt is useless. Unless you're a farmer. But I mean, we have things that we don't think are valuable that are contained of mass. And really, that's where all energy comes from. Mass boundaries, winding down, converting to the charge boundary, right? We know many ways to extract energy and convert things using the charge boundary right now, right? Chemistry does a lot of stuff. We understand how to intersect with that a lot. But we've never, other than an atomic bomb, by intent, intersected with the mass boundary and extracted energy from it, right? That's available right now for all of us. And the only thing you need to have in order to do it is an understanding of what reality is. Literally sitting around us right now is more value than any of us have ever tried to comprehend. We can't really conceive it in the world we're currently occupying in our minds, right? There's more value around us right now than you can conceive, but you can't access it. You can't tap into it until you know it's there. People didn't tap into electricity thousands of years ago. They didn't talk about electrons. They didn't know it was there. It was, right? Same thing here. We have a structure of reality. We have rules binding everything in physics and chemistry. Apparently, we may need to be more detailed as we go into chemistry, but it looks like it's mapping up. It gives us exact same numbers of available clockwise and counterclockwise loops of the number of periodic table elements, the elements in the periodic table. So I don't have the picture, but the picture is supposed to be these 32 things fitting together. Okay, and I'm strongly suspecting that's going to involve somehow pictorially 4 of these things. I don't know how they connect yet. Now, what about this half? I don't know. This is where I'm at. I think once we have that picture, we're done. I literally think we're at that last step. We have all the pieces of what things are supposed to divide into. We have how many pieces each thing's supposed to divide into at each scale. We just need to literally put it in a computer and have it model it, and maybe logarithmically model it so we can see each of the boundaries at the same time. I don't know. But that's where we're at. We need the picture.
So what you're saying is we've almost figured out what's going on.
Yeah, once we have a picture, once we have not just a picture, once we have animated, accurate picture of how these boundaries intersect, literally every place where the boundaries are forming, right? If we can show all that picture, which is going to look a lot like the gamma function and the zeta function, then we can show people what it means to go from helium to lithium, right? What that transform looks like, and therefore you intrinsically understand the difference between them. To have the picture in your head, then you're going to have to think there's some piece of action that's wrapping back on itself and closing off a piece that I can't see. So from the outside, if I'm going to be in that and look at the picture from there, there's a hole from the outside, and that small hole is this guy. Okay, but we're in the outside of it, and all the other pieces we get to see. And that's the question: what does the rest of that connect like? So basically, we've explained the whole, we've explained the other pieces are going to be in terms of equations, but now we need to get the picture that fits them all together.
Yeah.
You kind of see what I'm saying? So I didn't give you an exact answer yet, but I'm telling you how I'm going to get the answer.
Okay. I was only asking you to explain our level for. So I mean, that was all.
Yeah. It's getting more visual, right? It's getting more visual.
Yeah, I'm trying to make it.
I also like the picture here. We're trying to see how they break up into pieces, really, right? So if you think of the cone on cone picture and then the outside one sheet of hyperboloid on outside of it, fill in the gap between the two, right? Ignore the cage and fill in the whole gap where the cage would be that separates the two. The two surfaces don't touch each other all the way. They out there, they get closer and closer and closer, and here they separate, right? So there's a volume on the inside missing from the structure on the outside.
Yeah.
Okay, so when we're going to do an alteration in that structure, that's just if we hold at our minimum state. But what if we want to become lithium? We need to do an extra one of these somewhere, right? So let's take that top bowl-shaped piece and get it to somehow get a loop in it. It's going to be pinched off. And they're just going to keep doing it, though. It's not going to just pinch off once. It's now just going to orient itself so that it's always pinching a new volume there, right? So it's always going around a new extra path. Okay. So I think that's somehow how it's going to be state to state to state to state to state. We're going to use that hyperbolic structure on top of the hole itself, and we're going to add more energy down here at the hole, which pushes this one out.
Right.
Yeah.
So does that mean we're alchemists?
Yeah, that's our goal. We're not alchemists until we achieve it. But our goal is basically that we're trying to convert current states, chemical matter states, into different chemical matter states. So we're trying to literally take intersections of charge, mass, and temperature boundaries and rearrange them into a different set, extracting energy along the process, right? So we get a new way of taking energy from the mass boundary. But then we also get the understanding of how to not just use that energy for an explosion, in order to use it for transformed states of stability, to actually then have godlike powers. As long as you have access to mass, you have access to any arrangement of mass you desire. You have to know it to desire it, I guess, but you have to know of it, and you just have to have an equivalent or more mass to put in the machine, right, to get there. That changes everything about infrastructure, economy, dependencies, relationships, right? This changes the world humanity lives in. We won't be the same sort of species we are now, dependent on the yoke of society as it is so far. We'll be literally free, but not dependent on resources, right? Resources will become trivialized, part of just the experience. You get them for wanting them, just like you get for breathing. Yeah, so that's a different world to live in. And I think when people are all elevated to that, we're not fighting over resources or prestige over who has the most resources. Everyone will have all of them. So when that's not an issue anymore, what do? We wake up to the greater possibilities in existence, right? We don't have the threats and the lower thoughts of humanity really there anymore. They're not being fueled. So we're all free to develop deeper conversations with each other, to ask and try to make up stories that make sense of things, push all the way to the end of a story and get there instead of cut yourself off, because we're all full of doubt now and we're all seeing everybody else attack it and you're like, oh, that sounds wrong. Making a story is a start. Correcting the story is the process. Yeah. So I think we're going to all elevate into something like that. I think we're going to become a species of people who have different kinds of relationships, ones that are far more intimate, far more cerebral, far more connected, full of questions and excitement of exploration together. Because no one you meet is going to drain your resources.
Yeah.
They're only an opportunity to grow together in insight. And everyone you meet in a world like that, you better believe is going to have some experience, which is, by the way, free to give to you in that world. And so everyone you meet is going to be a source of delight, not a source of potential harm, right? Not something you should shield yourself against or protect or worry. No, it's going to be a completely different way of looking into reality from birth on. Yeah. And that's the sort of thing I think we should search for. These sorts of understandings aren't just about playing with numbers or liking geometry. It's about converting yourself to somebody who has the ability to use its own environment for all of its wishes.
It's also a gorgeous story as well, because it took the sum total knowledge of humanity to help get here, and we're using it to help decode our realm of existence.
Yeah.
Yeah.
That's pretty cool.
What's more fun than using the facts of nature that we've spent all this time up until now to get? Right, to collect. We didn't even know about most of those facts just, a few hundred years ago? Yeah, then using those things to find a story. I mean, what's more fun than that? The process is what I'm talking about. To use those things searching for a story. That's beautiful.
It allows us to focus on imagination and creativity.
Yeah.
Be able to focus on those things. And
at
that point, the sky's the limit, space is the place.
Isn't that crazy that having an accurate physics model in your mind allows you to focus on creativity and imagination? Like, that's one of the best ways to get there. If you have a rich, accurate model, so it's able to predict things well for you of physics, and it interfaces with the world well, your imagination will also be well inspired. If it's completely accurate, if you get the whole picture, you turn into something with more imagination, more ability to turn what you're thinking into reality.
Yeah. Well, the crazy thing is, once we can get a visual instantiation of this, I'm just trying to think, I'm like, oh my God, what will the next generation be able to do? Because I'm just looking at what kids are able to do nowadays with just something like Minecraft. They're literally building entire worlds and stuff like that just from out of the thoughts in their head.
Yeah. World building is really, really fun, and everyone will get into it when you have the ability. I'm really looking forward to it. So what's the next steps? What do we need to do to pull off building a replicator? To get to the stage, at least, where we're starting the building part, what has to happen? We need a visual model, right? Which means that we've fit all the pieces together in a way that coherently makes sense to us. So we need to do that in the computer for sure. But we may need to also build a computer on it, from it, right? From that structure, from that logic. Because if it's going to be universal, then that would be the best design possible. we wouldn't have any leftover parts. But still, the main steps we should focus on next are what? Gaining comprehension in the pieces that we're still not understanding in the geometry. That's really what I think we need to know. And there are many ways to approach this. You can approach gaining comprehension in the algebraic side, understanding the algebra of all these equations, right? And the relationships between the algebra of the equations. Or the geometric side, geometric algebra, and then there's a conversion between both of these, of course. But they're both very informative ways to learn them. There's two outstanding things to focus on: the gamma function and the Riemann zeta function.
Yeah.
Why? Because the gamma function codes how things hyperbolically partition. A gamma of 5 was all over in our thing, right? So the gamma function is just there. It's the descriptor of hyperbolic partitioning. So we want it to be a central player for how our boundaries are breaking up, right? But the zeta function, it's almost composed of two gamma functions. Well, it's composed of two gamma functions, and there's an offset from a 0 to a 1 and a denominator of 1. Okay, so it's two of them fit together to cancel. They perfectly symmetrically cancel. But the zeta function lives on a much smaller scale than the gamma function. They're tied together. Why would they be on smaller scales? Because we have a balance made out of big and small. So my story at this point is that the gamma function is coding the big, and the zeta function is coding the small, of the way that these circle or two-dimensional action and two-dimensional action are breaking apart to fit together in their whole balance, okay? So there's another thing to say. The calculus, the whole field of calculus, encodes the rules of how these boundaries are breaking apart and fitting together. It's not that we need to discover the rules. We need to make sure that in our picture, it's exactly mapping the rules of differentiation and integration. But it also will then give us visual geometric access to the functions in calculus. All the e to the x, everything in calculus will be visually representable in our model. Every function in calculus is there, is what I'm saying, okay? Okay, so that's our plan, that's the path. You can take any of those, whichever one you're strongest at, keep developing it, because it'll make you feel inspired, but then dabble in the others, right? All right, and we'll all do it, but that leads us into investigation of series and products.